CataractCoach.com. Fluidic Analysis during Phaco Chop with our guest surgeon, Dr. NV Arulmozhi Varman from India. Now, this is a very dense cataract. You can see it's brunescent, very opaque. Trypan blue dye has been instilled. A nice rhexis is achieved. What's special in this case is Dr. Varman has a phaco machine that allows him to show the actual vacuum aspiration power on our screen here with this video overlay. And it'll also show us a graph of that as it happens. So you can see the ramp up of the vacuum. You can see the change in the fluidic flow in the eye, the phaco power, all the above. We'll be able to really analyze this. So for this dense cataract, a nice, generous 5mm capsule rhexis has been made. Now here's the Phaco Chop. Look what happens. Vacuum level climbs very high and the flow drops because it's occluded. That's great holding power. And now the nucleus can be chopped. So during chop, it's very high vacuum and almost no aspiration because the tip is occluded. So keep looking. The aspiration is very minimal. The vacuum stays high. So this is obviously a very experienced surgeon, a very dense cataract. And throughout, there's a great purchase or holding of the nucleus with such a high sustained vacuum. Now the vacuum level drops as the surgeon goes to remove a quadrant or further sub-chop. So you can watch this. The nucleus is rotated, vacuum level is low, flow is very high until you aspirate on a piece. Now you occlude the tip with high vacuum. That's the white graph. And now look at the top graph, the blue one. That's the flow, very low. And once this piece is emulsified down, you'll notice that you have the flipping of that. Aspiration goes very high once the tip is unoccluded or open. And the vacuum level drops. So a peristaltic pump requires occlusion to achieve the highest vacuum levels. So again, watch this carefully. There's the dense nucleus. So buzz in, vacuum starts to rise. Look at the white graph, very high. The flow drops. The phaco power is the bottom graph. That's applied to get a good burying of the tip in the nucleus. And this is a very dense nucleus. It's almost fibrous or leathery. So again, buzzing in. Vacuum levels high, flow is very low because the tip is occluded, energy is applied, and the nucleus can be chopped. This is a very important concept. The concept of achieving occlusion of the phaco tip in order to achieve the high vacuum level. So you occlude the tip, the vacuum level goes up, and then what happens to the flow? Well, the flow goes down. So let's watch again. Here, as this little quadrant is emulsified, the phaco energy is delivered. That's the bottom graph. The white graph shows the amount of vacuum, which goes up and down as the tip gets occluded. And then the top blue graph is the aspiration level. So this is a very nice technique here of Phaco Chop. And again, we're able to really understand how this works. So chopping a piece off, holding with high vacuum, very low flow. Look at the tip. The tip is occluded. That's why the flow is so low. Now, as we let go and break that piece off, we can aspirate it down so the aspiration rate goes up. Vacuum is there modulated in white, and then the bottom is the amount of energy placed in the eye. So you can see, look at the settings here carefully. On the bottom left side of the screen is ultrasound time. That's the amount of time of ultrasound that's being given. On the right side, let's look at the numbers here. The top is the foot pedal. It says it's in position 3 now. Underneath that, it says the bottle height is 70 centimeters above the patient's eye. That graph in blue is the aspiration flow rate. You can see a maximum of about 44 cc's per minute. And then the middle graph in white is the vacuum level. The maximum number there is 650 millimeters of mercury. The bottom level is the power. And interestingly, the power is only at about 60% or 50%. And this shows you can use a relatively low amount of power, here 50% of maximum, in order to emulsify even such a dense cataract. And the reason is the mechanical disassembly like this, the Phaco Chopper. And you notice this nucleus is so dense, it's required many, many chops. So the total number of chops in this case is maybe 20 or more. In a typical softer cataract, you may be able to do it with just 1 or 2 chops. And so again, understanding this concept, and this is obviously a very well-experienced master surgeon, we can see that the vacuum level compared to the flow rate that ratio and that relationship is very important to understand here. Here's the very last bit of the nucleus coming out of the eye. Well, look what happens. Vacuum is low. Look at the white graph. No vacuum yet. Now, buzz in with the phaco probe, vacuum level climbs, and then the flow rate drops. Aspiration rate drops to almost zero. And that looks great. The nucleus is split apart. There we go. Using the chopper to propagate that crack all the way through to really get two separate pieces. Now, buzzing in again and keeping the tip occluded with lens material. And then you can see the vacuum level is nice and high, about 500 maximum. As the piece comes down, there'll be periods where the vacuum level will drop. And then as the tip is occluded, the vacuum level goes back up. And on the bottom, we see the phaco energy. Again, highest they have is 50% power. So yeah, dense nucleus, 50% power. At the end here, watch carefully what happens. And as the last nuclear quadrant is coming up, the tip gets occluded. There's the high vacuum. Now it unoccludes. It occludes again. And then look what happens to the flow rate. You're going to take this piece down. Flow rate is going to drop because the tip's occluded. But as soon as that piece goes down, the flow rate climbs right back up very quickly.